Okay, dear students, let us see what is there in this question now. When 40 kilojoule of energy is transferred to a quantity of liquid substance, so the quantity is not given, its temperature increases by 20 Kelvin. When 600 kilojoule of energy is transferred to the same quantity of the liquid at its boiling temperature, it vaporizes completely at constant temperature. So the phase transformation is taking place. What is the ratio of specific latent heat of vaporization and specific heat capacity of the liquid for that substance? Okay, fine. So my dear students, as we all know that whenever the heat is supplied to a substance, it can be used in two manners. Like the first kind of heat is known as sensible heating. Now, what is this sensible heating? Sensible heat. Sensible heat is the heat which is when absorbed by a liquid, it increases the temperature of the liquid. So in this question we are going to compare these two heats, that is sensible heat and the second one is the latent heat. So in sensible heat we use the formula Q is equal to mc delta T, where delta T is the temperature, M is the mass of the substance, C is the specific heat of the substance, Q is the heat provided. Now, point number two, the second kind of heat is known as latent heat. And this is a heat, like the word latent means hidden. So this is a heat which is absorbed by the substance and it is just hidden because the temperature of the substance is not increasing. And why the temperature is not increasing? Because the substance is now changing the phase from liquid to vapor or from solid to liquid. Accordingly, it is known as like latent heat of vaporization or latent heat of fusion. For this, we use the formula Q is equal to M into L. So this is the heat that we have to supply. And in both of these cases, the heat is given to us. In the first case, 40 kilojoule is given. So this is sensible heat. And 600 kilojoule is given for the phase transformation. So it is definitely talking about the heat that was given for phase transformation. So accordingly, the first equation becomes Q is equal to mc delta T, and this Q is given as 40K, M is not known, C is not known, and delta T is given as 20 Kelvin. Now in second case, Q is equal to M into L, and heat given is 600K is equal to M, mass is unknown, and the latent heat is also not known. So now what we want is the ratio of latent heat to the heat capacity of the liquid. So we will divide this thing. This will be taken as like equation number one. This will be equation number two, and dividing the first equation by second, what we get is m into L divided by mc delta T is equal to 600K divided by 40K. So obviously the 1000 gets cancelled out and the 0 will be cancelling out. M and M gets cancelled out. We are just remaining L by C. So this K and K gets cancelled. This and this I can cancel it less 2. So this will be taken as 300. So L by C comes out to be 300. And the unit will be, this will be delta T. So this 20 will multiply there. So it will be Kelvin. So 300 Kelvin, the answer for this question will be D. So this is how we do it, my dear students. Now, there is one more point I would like to specify here. The specific heat capacity. So it should not be confused with heat capacity. There are two things like heat capacity. So this is defined for a body and heat capacity is equal to the product of M and C. And C is known as the specific heat or specific heat capacity. One is the same thing, and this relates with C, and that is this C we are talking about. Specific word means that you are dividing something by mass. When you divide something by mass, you call it specific. Okay, so this is how we do it generally. It's not like every time we do that, but generally it is correct that whenever we say specific, we divide the equation by mass. So we are only talking about C. Okay, dear students, this is Professor Varun. Please subscribe to the YouTube channel. All the best.